Today, we're going to tackle a question that might have popped into your head while flipping through your high school chemistry book, or maybe just randomly like a sudden spark. Something in the realm of the wildest what-ifs in the history of science. Imagine a scientist has a brilliant idea to throw all 118 known elements of Mendeleev's periodic table from hydrogen to oganesson into a giant blender. Yeah, you heard that right. It's like they're trying to cook up a Mendeleev-style atomic stew. What do you think will come out of it? A magical potion? A tasty atomic soup? Let's peel back the layers of this scientific mystery together, step by step, and see what's waiting for us at the end of this sci-fi journey. I promise your brain's fuse might blow by the end. But hold up, before we dive headfirst into this atomic chaos, we need to clear one thing up. We need a container. Not just any container, but something that won't melt under heat, won't react with any substance, and won't burst like a balloon. Something on the level of Tony Stark's armor, but 100 times stronger. Because trust me, my friend, without something like that, the game's over before it even begins. Now let's assume we have that super container. We start adding the elements. The first thing that becomes immediately obvious is how different they all look. Gases like hydrogen, helium, nitrogen, oxygen, that bully fluorine, and troublemaker chlorine, along with the rest of the noble, laid-back gases, start swirling around, mixing and mingling. Down at the bottom, liquids like silvery mercury and deep red bromine gather in one corner, and the rest, they're solids from soft hyperreactive metals like sodium and potassium that act like they just broke out of prison, to the heavy dignified metals like gold, platinum, lead, and of course Mr. Uranium. Even before we get to the wild chemical reactions and fireworks shows, a whole bunch of small and big events start happening right away. For example, those naughty alkali metals like sodium and potassium. Just a whiff of moisture is enough for them, which definitely exists in that mix, unless we're in absolute vacuum, which is a whole other story. And they start reacting fast and producing hydrogen gas. Now take that innocent hydrogen gas, pair it with ever-present oxygen, and just a tiny spark. Boom! We've got ourselves a cute little explosion to kick off the party. Well, little only applies if we're just thinking about sodium and potassium. When all 1108 elements are in play, the game changes completely, big time. Now let's move on to the main event, chemical reactions. This is where it gets truly wild. Some of these elements absolutely hate each other. Take fluorine, for example. It's known as the gangster of the periodic table and reacts with almost anything you can imagine. And not just any reaction, explosions, fires, smoke, and chaos. Now throw this angry fluorine in with alkaline earth metals like calcium and barium, or even with other metals, and what you get is an industrial scale fireworks show. Tons of different salts form, releasing so much energy it could wipe out a small town. It's like we've thrown the craziest party ever, where everyone's fighting and throwing punches. Oxygen, that's just the icing on the cake. Many elements, especially metals, are madly in love with oxygen, and as soon as they spot it, they immediately enter oxidation reactions. Translation: burning, rusting, and lots of exothermic heat-releasing reactions. Now imagine this insane heat spreading to the other elements. The temperature of this hellish mix begins to rise. Not just a few degrees, we're talking hundreds or even thousands of degrees Celsius, buddy. At that temperature, most solids can't handle it anymore and melt. Liquids start boiling like crazy, and gases, well, they go berserk, expanding more than ever and putting insane pressure on the walls of our magical container. But you think that's the end of the story? Nope, my dear. Some of the main players haven't even entered the scene yet. A group of elements have been sitting quietly in a corner until now, but once they join the madness, there's no stopping them. I'm talking about elements like uranium, thorium, plutonium, and those super heavy, unstable ones like oganesson. These guys spontaneously begin decaying and emitting alpha particles, beta particles, and gamma radiation. What does that mean? It means our hellish mix, which was already scorching hot and highly pressurized, has now become lethally radioactive. It's like walking into the heart of a nuclear reactor that's in the middle of exploding. A total hellscape, both burning and radioactive. Those gamma rays, they're pure energy and can slice through chemical bonds like scissors, triggering new, unpredictable reactions. Alpha and beta particles are invisible bullets that collide with the nuclei of other atoms, transforming them into different elements. What does that mean? It means our periodic table is no longer that neat, beautiful chart we know. It's turning into Play-Doh, constantly changing shape. One element turns into another, and the cycle goes on and on. This is nuclear alchemy in action, but not the type where people tried turning lead into gold. This one's way rougher, more brutal, and completely out of control. It's like nature itself has gone mad. Let's take a deeper look at this catastrophe. All that energy from the explosive chemical reactions and relentless nuclear decays. Where does it go? Obviously, it all turns into heat, light, and various forms of radiation. The temperature of our bizarre mix shoots up so high that we're no longer talking about regular liquids or gases. Most likely, the atoms can't even hold on to their electrons anymore. The electrons break free from the nuclei and become ions, which means we're now dealing with plasma, the fourth state of matter, the kind found in the sun and stars. A super hot ionized soup of bare atomic nuclei and wandering electrons that also emits powerful electromagnetic waves and deadly radioactive radiation. Something like what happens inside stellar nuclear furnaces. But here, it's way more chaotic, disorganized, and far more dangerous. Our magical container, no matter how strong, whether it's made of vibranium or any other fictional supermetal, will eventually give in under this unimaginable pressure and heat. If this evil mix somehow leaks out, and with that much energy, it probably will, an environmental disaster unfolds that even the worst sci-fi movies haven't dreamed of. The entire surrounding area becomes heavily contaminated with radioactive and toxic chemical materials, making it uninhabitable for thousands of years. It's like we brought a piece of hell down to Earth. Now, a very important question. Will we actually end up with a mix? Or is it more like a full-blown battlefield where the elements are tearing each other apart, transforming into one another, and creating pure chaos? Honestly, the second option is much closer to reality. What we'll eventually be left with, after all the rapid explosive reactions are over and the temperature finally, which may take thousands of years, starts to drop, is probably a collection of the most stable isotopes of the various elements. These will likely be trapped in a glassy or ceramic-like matrix made up of oxides, silicates, and other super stable compounds. And of course, many of the heavier elements will have decayed into lighter, more stable ones over time. Maybe something like the strange substances scattered after a supernova explosion in space, but on a much smaller, denser, and much more chaotic scale. It's interesting to know that something vaguely similar has actually happened in nature, though not with this level of intensity, speed, or number of elements. For example, in a natural uranium mine in a place called Oklo in the country of Gabon, Africa, about 2 billion years ago, due to the high concentration of uranium and the presence of groundwater, a natural nuclear reactor spontaneously activated and operated for several 100,000 years. So mixing all the elements of Mendeleev's periodic table together is like opening a cosmic-scale Pandora's box and unleashing an unimaginable chaos. From the initial chemical explosions and hellish heat to relentless nuclear decay, scorching plasma formation, and element transformations, it's a deafening symphony of destruction and chaos. And the final result? An ultra-radioactive, scorching hot, unpredictable, and probably very smelly mass, full of bizarre compounds and new elements that barely resemble the original ones. If you enjoyed this video, please support Factorium by liking and subscribing. Thanks for watching.